All right, so I just took a little bit of time to go over the derivative of e to the x, so I'd like to actually use that in context of the product rule. So let's kind of see how that fits in context of some problems where it would become necessary. Now in class we learned something that if you ever take the derivative of the product of two values, what happens is you take f prime g plus g prime f. Now, I actually wrote that opposite. I wrote this first and this second in class, but it's the same thing. Now, often we will just express it as f prime g plus g prime f, just to be a little bit safer and faster. But the reality is, remember, these are called operators. It's the derivative of f with respect to x. And so those x's should be there, but sometimes, just like everything else in life, we will, we'll say what's up, or sup, we'll just try to abbreviate things to make it a little bit faster and more convenient. So if you were asked to take the derivative of a function 3x squared minus 1 times say 7x to the third minus 2x plus 3, we have two options. One is we could distribute the whole thing out first and then take the derivative, or according to this rule, we could take f prime g plus g prime. So there was f prime g plus g prime f, where g prime would be 21x squared minus 2, and f would still be this. Now, really what we're supposed to do is then clean this up a little bit, take the time to write 42x to the fourth minus 12x squared, 18x. See, unfortunately, when you do the product rule on a polynomial, sometimes you end up creating a story for yourself that's maybe a little bit harder than you wanted to create for yourself. You kind of do an awful lot of work, and then we still have one more step, which is to kind of combine my like terms, which is kind of why a lot of people would not actually encourage you to use this version of product rule at this time. So let's see, at negative 33, I think it's negative 39x squared, and I got 18x's and a plus 2 out at the end. Probably would have been faster to do the other way. But unfortunately, sometimes we have stories like this, where you have, let's say, e to the x times 4x cubed minus 7x plus 1. Well, guys, that is not a problem that we could actually do using the other rule. So f prime, I'm going to again call this f and I'll call this g. So if I did f prime g plus g prime f prime is e to the x g, leaving it alone, plus g prime, that would be 12x squared minus 7, times f itself, which is the original function. So there's f, there's g. Kind of goes pretty quick. And so I could simplify that and say, hey, you know what? Both of these terms have e to the x in it. So if I factored it out, I would still have a 4x cubed. I'd still have a 12x squared. I'd still have my negative 7x. And I'd have a 1 here and a minus 7 here, so minus 6. And I actually now have done the product rule, and I have those separate. Now, another little idea that would actually work really nice for this particular story, again, sticking to e to the x because that's the only one of these kind of functions we've done yet, is what if somebody said, I wanted to take the derivative of this? Now, some teachers would tell you that you have to do the quotient rule on that, but we can actually look at it this way. We could say that's the product of e to the x and x to the minus 3. So if I consider this function f and this function g, again, the derivative g prime of x would be f prime g plus g prime f. Probably shouldn't keep using the same letters, but I always use f and g. So f prime g plus g prime f. That looks pretty good. And so if I again factor that e to the x out, I'd have 1 over x cubed from the front side, 3 over x to the fourth from the back side, and we finished our story. So that's a little quick idea about doing the derivative using the product rule, specifically in conjunction with the derivative of e to the x. Hopefully that was helpful. All right, goodbye.